So this is module 2. So the first concept here are, of course, under the umbrella of fractions. First, we're going to differentiate between prime numbers and composite numbers. Prime numbers are those numbers that cannot be divided by anything else but 1 and themselves. So for example, 2 has only 2 factors, 2 and 1. 3 the same, 5 the same, 7 the same, 11 the same, 13, and so on and so forth. These are prime numbers. They only have 2 factors, themselves and 1, nothing else. What is a composite number? Anything else. For example, 6 is divisible by 1, by 6, by 2, by 3. Therefore, 6 is a composite number. Because 6 can be divided by itself and 1, but other factors, at least 1 more. So it's not a prime number. Okay. When we talk about fractions, and somehow fractions terrify people, I'm not sure why. So a fraction can be anything m over n, anything. It can be 1/2, 2/3, 5/6, and so on and so forth. It can be negative. It can be negative 1/10, negative 2/5, and so on and so forth. Right? And anything, if you remember from the proportion situation, anything can be presented as a fraction. 5 can be presented as a fraction. X can be presented as a fraction. 1500 can be presented as a fraction. Okay. Now, how do and I showed a couple of examples, but let's show another one. So let's say I have 35 divided by 140. I'm asked to present this fraction, present it in lowest terms. Presenting a fraction in lowest terms means removing all possible factors. In other words, 1/2 is presented in lowest terms. No one can further simplify this. 2/3, the same thing. 5/6, the same thing. And all the numbers, all the other fractions that I presented, they're all in lowest terms. Okay. How do I present 35 over 140 in lowest terms? I have to simplify based on divisibility. These are not even numbers. This is an even number, but this one isn't. So starting with 2 is not going to work. What about 3? No, it's not going to work because 3 plus 5 is 8, and 8 is not divisible by 3. Therefore, 35 is not divisible by 3. I can jump ahead and say, I already know. Both numbers end in 0 and 5, which means both numerator and the denominator can be simplified by 5. So 35 divided by 140, I simplify by 5 and I get 7. I simplify by 5, and what do I get? I get 28. So at this point, I have the fraction 7 over 28. So I move on. I try 2. I didn't try. I thought of 2 and 3 and now 5. Now the next prime number is 7. Are top and bottom divisible by 7? Yes, it happens that they are, right? So 7 divided by 7 in 1 and 28 divided by 7 is 4. So therefore, this fraction simplified to the lowest terms, which is 1/4. How did I do that again? What was the thinking process? I tried prime numbers. The factors that I know the divisibility and the sum of the prime numbers, like divisibility by 7, I didn't know any rule. So I simplified and I got 1/4. So that's what it means to present a fraction in lowest terms. Now, one thing that I wanted to make it clear is this. This, although it doesn't look like it, is the same with 7/28. Although it doesn't look like it, it's identical with 38/140. That's why the equal symbol. So these are called equivalent fractions. They are the same in value. They don't look the same. 35/140, 7/28, and 1/4, they don't look the same, but they are equivalent. All are equivalent fractions. Equivalent fractions. Okay. Now, I would like to move on to adding, first of all, multiplying and dividing. Okay? Multiplying and dividing fractions. So here is an example. Let's say I have 1/2 multiplied by 4/7. Are these two fractions? Yes. Are they in lowest terms? Yes. When I multiply fractions, I simply need to multiply the numerators separately and the denominators separately. However, please don't do that before you simplify. So I'm going to write simplify first. Simplify first. Because then you may end up with a huge number and you will not know what to do with it. And then you'll have to go backwards step by step and simplify it anyway. So the best thing to do is simplify from the beginning. You cannot simplify numerators. You cannot simplify denominators. But you can simplify from the denominator by 2 and from the numerator by 2, because these are factors. Please understand, you will never be allowed to do this in a division. You cannot simplify this and this in addition, sorry. This is not allowed because they are terms, not factors. If you remember terms, with terms we have limited playroom. With factors we are empowered. So I simplify 2 by 2. I simplify 4 by 2. Now, only now, I multiply. 1 times 2 at the top is 2. 1 times 7 in the denominator is 7. And I got the simplified form. And it's also in lowest terms. So I multiply those two fractions. And the final answer is already presented in lowest terms, which is a must. Any questions? Okay. Let's look at the division. What if I have the following? Let's say 2/3 divided by 10/9. When I divide fractions, the rule says copy the first fraction with no change and multiply instead of divide, change the multiplication, the division into multiplication by the multiplicative inverse. Multiplicative inverse, 9/10. So first I have to change the division into multiplication. Then I have to simplify and then continue. Can I simplify? It doesn't have to be the case. It's the case here because I chose examples in which I can simplify, but it doesn't have to be. So I'll simplify not numerators and not denominators. A factor from the numerator by 2 with a factor from denominator of 2. A factor from denominator of 3 with a factor from the numerator of the same thing. Now the numerator has 1 times 3, which is 3, and the denominator has 1 times 5, which is 5, and it's done. And the result is in lowest terms. I don't have to do anything else. Next, there are basically 3 types of fractions. One that we already talked about, lowest terms. Done. But there are other 2 fractions. One is called improper. Improper fraction. And the other one that is called a mixed number. The lowest terms, we know what we mean by that. A fraction in which the numerator and the denominator have been stripped of common factors. Done. There's nothing else I can divide them by. They have no more common factors. Now let's talk about the improper fraction. And then we talk about the mixed number. What is an improper fraction?
10/5.
Say it again.
10/5.
Yes. However, 10/5 is already 2. But let's say 9/5. Very good. Good. Why is this an improper fraction? Because the numerator is greater than the denominator. Notice that in all the situations that I looked at or presented so far, that was not the case. This was not the case. The numerator was smaller than the denominator. But if the numerator is greater than the denominator, this is called an improper fraction. Now, an improper fraction can be converted into a mixed number. So if we come back here, just for you to remember, lowest terms, let's say 2/5. An improper fraction, let's say 9/5. Oh, I didn't mean that. Okay? And then we'll come back to the mixed number. Okay. So what is a mixed number? A mixed number has an integer, a remainder, and a divisor. Okay, how does this look like? 9 divided by 5. I know that 5 goes into 9 once. But 5 times 1 is 5, and subtracted from 9, we have a remainder of 4. The improper fraction was converted into a mixed number. And of course, we can go back and forth. From a mixed number, we can go back to an improper fraction. From an improper fraction, go back to a mixed number. How do I go back? 1 times 5 is 5, plus 4 is 9. That's how I check my work. Good. So let's look at a few examples. So coming back here, so you have the examples together. 9/5, 1 and 4/5. Good. So let's look at a couple of examples. So let's say 17 divided by 3. So let's work on this for a moment. And let me know when it's ready. Can anyone help with this one?
Five and 2/3.
So we have 5 and 2/3. Is everyone in the clear with this? It's okay if you say no, and I'll explain.
No.
Okay? So when we divide 17 by 3, we get 5. 5 times 3 is 15, and the remainder is 2. 5 times 3 is 15, plus 2 is 17. Is this okay? What if I want to go backwards now? So, for example, 3 and 5/6. Let's work on this for 30 seconds. Can anyone give us the mixed number now?
23/6.
So we have 3 times 6 is 18. 18 plus 5, 23 over 6. Everyone agrees with this? Okay, perfect. Good, so let's move on. What if I want to represent, let's say, -1/2 on the real line? I draw the real line. And negative, so this is 0 in the middle, negative infinity and infinity. Where will I plot this? Well, so let's say this is -1. And -1/2 would be right in the middle, between -1 and 0. Do we agree?
Yes.
Any questions? Any questions? Okay, here's the next step. Let's suppose, let me see,